Today we're going to talk about square root functions and graphing those. I want my highlighter here. Alright, so if a function contains a square root of a variable, it is called a square root function. Okay, square root of a variable. Okay, the square root function is a type of radical function. Okay, so if you hear me say radical, it is because it is a radical. Okay, that's what that square root symbol is. Alright, so our parent function of square root functions. So here's our parent. Okay, it's the square root of x. Okay, and it looks like this. Okay, so point at 0, 0. Off and to the right, it kind of curves like a sideways parabola, but it only has that single line right there. Now your domain has to be greater than or equal to 0. Okay, if I were to plug in a negative number for x, you would have an imaginary number and you can't graph those. Okay, so that's why our domain has to be greater than or equal to 0. Whatever's under that radical symbol there. Your range just depends on your y values, so where your function starts and then goes off to. So it's going up, so it has to be greater than or equal to 0 there. Intercepts, end behavior, stuff like that, don't worry about. We can worry about that later. So first thing I want to do is find the domain. Okay, so we're going to practice finding the domain and range of these radical functions. So the domain of a square root function is limited to values for which the function is defined. Okay, meaning whatever's in your radical symbol has to be greater than or equal to 0. So finding domain and range of each of these functions. First, you find the domain. So I take what's ever under my radical symbol here. Okay, in this case it is x minus 3. I take that and it has to be greater than or equal to 0. And I just want to solve for x. Okay, so to get x by itself, add 3 to where x is greater than or equal to positive 3. Okay, so this is your domain. That is how you find your domain of a square root function. Whatever's underneath that radical symbol is greater than or equal to 0. Okay, so here, all of our x values, such that x is greater than or equal to 3. Okay, that's our domain. Now for your range, what you're going to do is plug in what you found for your domain. Okay, so plug in that value you found for your domain for your x. Okay, so I have the square root of 3 minus 3. Okay, and that's just the same, so this has to be y greater than or equal to 0. Okay, so for each of these, you're setting it to greater than or equal to 0 to find that range of values. So our range, our y, such that y is greater than or equal to 0. Questions? We doing okay? Mm-hmm. All right, next one. This one's a little bit different because it has this +2 on the outside of that radical symbol. So again, first I want to find the domain. To find the domain, we just take what's underneath our radical symbol, which is x plus 6, and that has to be greater than or equal to 0. Okay, just whatever's underneath that radical. Solve for x. So I'll subtract 6. So here, x has to be greater than or equal to negative 6. So that's your domain. Okay, those are x values. And x has to be greater than or equal to negative 6. Now I want to find my range. So to find my range, I plug in negative 6 for x. So again, our y values, we're going to do greater than or equal to. Plugging in negative 6 for x. And this time I do need to add in that plus 2 on the outside. Okay, so you're just plugging in your domain into your entire function there. So we have y is greater than or equal to square root of 0 plus 2. Which is y is greater than or equal to 2. Okay, square root of 0 is 0. So that would be our range for this one. And those are our y values. Now I am using greater than or equal to here because I know my function is positive. Okay, for your range. If your function is positive, use greater than or equal to. If this had a negative outside, your function is negative and you'd say less than or equal to. Does that make sense? A little bit. Maybe. I'll go over that a little bit more in our chart below here. Any questions on finding domain and range before I continue? All right, so we have different transformations here. I'm going to get out different colored highlighters. If you have any, that'd be awesome. I don't know where my orange one is.
You want another yellow?
Well, no, I have some, but if you have different colors, it would work better. So here is our parent function with different values. So I have f of x equals a times the square root of x minus h plus k. Okay, each of these values, a, h, and k, do different things to your function. Okay, so first, h. H is right here. That is a horizontal translation. It moves your function left or right. Okay, so whatever value is underneath your radical along with x, it moves your function left or right, depending upon if it's positive or negative. We also have, no, just this one. We also have this k on the outside. I'll do yellow. Okay, k on the outside right here. That is your vertical translation. So that moves your function up and down, depending upon if k is positive or negative. Okay, so whatever's outside that radical symbol moves it up and down. Okay, the last one here is a. I hope this isn't too dark. Okay? Yeah, it is. Okay, so a outside here has to do with orientation and shape. Okay, so if a is positive, it's a normal square root function curve. If it's negative, it's going to reflect in the x-axis and kind of dip downward instead. Okay, so if a is negative, it dips down. Now if our a value is greater than 1, it's going to stretch it vertically. So it's going to actually go up and out more instead of more curved like normal. If a is a fraction, so between 0 and 1, or a decimal, it's going to compress. So it's going to get closer to that x-axis rather than further away from it. Okay, so those are what each of those values do. So we're going to use that on the next page here. You can ignore that last page. I forgot to exit it off, so we're not even going to use it. So if you want to tear it off and throw it out, you can. So looking at example 2, we want to graph this function and state the domain and range. So first thing I like to do is find my domain and range. Okay, so we're going to do that just like we did our first problem. So take whatever's underneath your radical here, which is x minus 4. That value has to be greater than or equal to 0 for our domain. Okay, so add 4. So our domain here, x has to be greater than or equal to 4. And I can write that out right away. Next is our range. So again, I'm going to plug in 4 for x in my function here to find my range. Since my outer number right here is positive, I know my y values have to be greater than or equal to that function. Okay, plugging in 4 for x, and then add 2 on the end there. Now when I do this, I should always get 0 underneath my radical. Okay, you should always get 0 here. So we have 3 times the square root of 0 plus 2. 3 times 0 is 0. So y has to be greater than or equal to 2. And I can write that as my range. Okay, next what I want to do is find my a, h, and k values. Okay, a is on the outside of your radical or square root symbol, and it's multiplied to it. Okay, that is 3. Okay, since that value is greater than 1, this is going to stretch vertically. Okay, so it's going to stretch vertically. It's going to get further away from the x-axis. Next, we have our h value. Okay, h is the value underneath your radical. Okay, that is 4. Now, for your h value, this looks like negative 4. You always do the opposite for your h value. Okay, you always do the opposite. So if this was x plus 4, your h value would be negative 4.
Really?
Okay, since it's x minus 4, your h value is positive 4. Okay, that moves your graph right. Okay, it'll move your graph right 4 units. Okay, last one is your k value. That one is on the outside of that radical. Okay, that value is 2. That one you do not switch the sign. Okay, so since it is plus 2, it stays as positive 2. The only sign change here is your h value. So that one moves it up and down. So that one will move up 2 units. Alright, so what I'm going to do is kind of graph your parent function so that we can actually see how this moves using those values. So your parent function is just the square root of x. So that one, you have a point at 0, 0. You have a point at 1, 1. You have a point at 4, 2, and 9, 3. Okay, so all I did, I took the square root of 1, that's 1. Square root of 4 is 2. Square root of 9 is 3. Okay, so this is your parent function. Okay, that's not the one we actually have to graph. We have to graph this one. I'm just going to move this one using these values. So first ones I want to do are h and k because it's a little bit easier to move those points. So starting with 0, 0, I have to move that point right 4 units. So 1, 2, 3, 4. And I have to move it up 2 units. 1, 2. 2, right here. Okay? The next thing I want to do is actually multiply that by 3. But since I started at 0, 0, multiplying it by 3 is just going to result in 0. So this is my first point here. Now again, if you don't understand how to move your graph using the parent function, that's okay. I'll show you how to do your XY chart as well. Okay? From here, so this is our first point. Next we have this point of 1. Okay, I want to multiply that by 3. So 1 times 3 is 3. Okay, moved it up. Then I need to move 4 units to the right. Okay, and 2 units up. I think I did that right. Yes. No. Should be here. So our function kind of goes off this way. But I am going to show you the XY chart. Okay, so we're going to plug in points. Now, since your domain is x has to be greater than 4, you should start with that. Okay, don't start with -1, 0, 1, anything like that. Start with your domain. Okay, so start by plugging in 4. Okay, if I plug in 4 to my function here, I have 4 minus 4 is 0. Square root of 0 is 0. 0 times 3 is 0. Plus 2 is 2. Okay, so I have a point at 4, 2. Okay, next I'm going to plug in 5. Okay, if I plug in 5 here, I have 5 minus 4 is 1. Square root of 1 is 1. 1 times 3, 3. Plus 2, 5. So I have a point at 5, 5. Okay, next one I want to plug in, let me see here, is 8. I'm making the square root a little bit easier to work with. So if I plug in 8, I have 8 minus 4 is 4. Square root of 4, 2. 2 times 3 plus 2.
8.
So it should go up this way. Okay, so you still can use your XY chart here. So just plugging in points that make that square root a little bit more manageable. So that's why I plugged in 5, because I knew 5 minus 4 was 1. I could take the square root of that. That's why I plugged in 8. Okay, 8 minus 4 is 4. I could take the square root of that. Does that make sense? Yeah? All right, last thing here is a square root inequality. Basically the same way, except you have to decide whether your line is solid or dashed. Okay, solid or dashed line. And you have to pick a point on your graph to see where you should shade. Okay, so it's that set of all points above or below that line. So a square root inequality is an inequality involving square roots. They are graphed using the same methods as other inequalities. So last example here, first thing I do when graphing inequalities is I look at that inequality symbol. Now since this one doesn't have a less than or equal to, that means it is a dashed line. Okay, so I need to make my line a dashed line when I graph this. Okay, so again, that's if you have just this symbol. If you have a less than or equal to or a greater than or equal to symbol, that is a solid line. Okay, so make sure you're looking at that symbol first. So with these ones, I don't do domain and range because you have a set of points that is your answer. So from here, I'm just going to find what A, H, and K are, and then I'll make my XY chart for you. Okay, so A. What is A in my graph here? -1. Okay, so if my A value is negative, it reflects it over the x-axis. Okay, so it reflects in the x-axis. Next, I need my H value. What is my H value? -2. Okay, so that means it's going to move left 2. Okay, and then K. Where's K? It's -4. So it moves down 4. Okay, and this time I'm just going to make my XY chart because I think that'll be a little bit easier for you. So I'm still going to start with my H value here. Okay, so I have -2. So I'm going to plug in -2 for x. So if I plug in -2, I have 0 underneath my radical. Yes? Okay, square root of 0 is what? 0 minus 4. -4. Okay. Next, let's plug in. Let's plug in 2. Okay, again, I'm plugging in numbers that I can take the square root of. So if I plug in 2 here, I have 2 plus 2 is 4. Square root of 4 is 2. Now I have this negative out front. You need to multiply that number by -1. Okay, so if I have -1 times 2, it's -2 minus 4. -6. All right, so next number, let's plug in. What's another good square root that I can take the square root? Any number. What's a good number? We just did 4. 9. So how do I make what's ever under my radical 9? What should I add to 2? 7. So I'm going to plug in 7. Okay, so plugging in 7 here. 7 plus 2 is 9. Square root of 9. 3. 3 times -1. -3 minus 4. All right, so now I have 3 points. I'm going to plot those points. Okay, so -2, down 4, +2, down 6, +7, down 7. Now recall that I wrote out that this has to be a dashed line. Okay, remember to look back at your inequality symbol. Okay, this is a dashed line. Last step for inequalities, you have to test a point. Okay, a point that's not on your line here. I always test 0, 0 if it's in my domain, because that's easy to plug in, right? So I want to plug in this point 0, 0 into my original equation. So I'm plugging in 0, 0, 0, 0. I'll write that out. Plug in 0, 0. for your x and y value. Now y is just f of x. So I would end up with 0 is less than the negative square root of 0 plus 2 minus 4. Okay, so I have 0 less than negative square root of 2 minus 4. Now, if you were to plug this into your calculator, right, just to get a decimal, okay, we're just testing to see if this is true. If I add these together, won't my answer be negative? Yes. Okay, is your negative number greater than 0? No. Okay? So this statement is not true, meaning I'm not going to shade where 0, 0 is. I'm going to shade everything below my line instead. Okay, now it can't go past that domain point there of negative 2. Okay, so my shading has to end there and go beyond that. Okay, do you remember inequalities where you have to shade and pick a point? Yeah? Do you remember doing that? Okay, again, it's always easier to just pick 0, 0 because it's way easier to plug into your equation. So if this would have been true, I would have shaded everything above my line that I graphed. Okay, any questions?